Good evening, ladies and gentlemen, and welcome to the Recreational Astronomy Night for December 2024. My name is Tom Luton. I'm going to be your host this evening. Our usual host, Paul Markov, is unavailable. This evening we've got a short program because our annual meeting of the Toronto Centre of the Royal Astronomical Society of Canada is immediately following our meeting. Tonight we've only got two presentations. Claudio Oriani will be talking about the sky this month, and Arushi Nath will be talking about using N-body simulations to analyze transit timing variations in multiplanetary exosystems. Let's get the ball rolling with the sky this month and Claudio Oriani.
Thank you, Tom, for having me tonight, and good evening, everyone. That's Claudio Oriani from Richmond Hill. Tonight I will talk about the sky of the month of December. Note that during my presentation, all times are expressed in Eastern Standard Time, and unless otherwise noted. There's so much going on this month, so without further ado, let's start. At glimpse, we have Jupiter at opposition on Saturday, September 7th, so it's coming now. We have 3 meteor showers, so the Gemini, and also the Quadrantid, and also the Ursus. There are lots of going on. We have the winter solstice. The Mars is going to be very close south of the Moon. Unfortunately, there is no occultation this month, but good news, there will be an occultation next month. I will tell you later. And also Antares will be very close of the moon at the end of the month. And we will reach perihelion on Saturday, January the 4th. Not much to say about the sunrise sunset. As you can see, today the sunrise was at 7:34 a.m., while the sunset was at 4:40 p.m. So we basically had 9 hours, 6 minutes of daylight. While on January 8th, we have just 2 minutes more of the daylight. So it's really changes so much. What happens is that it's pretty much the same. So what does it mean? It means that the astronomical twilight and today at the 6:23 when we have, as you can see, 11 hours and 29 minutes of imaging time, while on January 8th, we have 11 hours, 26 minutes. So we have a bunch of time to take imaging. The sky. So basically tonight at 9 p.m. you can see Cassiopeia, Andromeda, Perseus, and Pegasus. The fall constellation are overhead, so take advantage if you have the clear sky to take images to look at this constellation. While Taurus, Gemini, and Auriga are also well positioned high in the sky. Around 11 p.m., Orion, Canis Major, the Sirius, Monoceros, the unicorn, will get higher in the sky, not too high at our latitudes. One thing you can notice for this month, the winter hexagon, that basically is a large circular pattern made of some of the brightest stars. It's not a constellation. And we have Rigel, here in Orion. And then we have Aldebaran in Taurus on the top here. We have Capella in Auriga. And we have the twins, Castor and Pollux. Pollux in Gemini and Procyon in Canis Major. So you can see a circle. The brightest star around, they are getting high in the sky. Today, if you look at southeast to southwest horizon, you can see Saturn in Aquarius, and this other circle is Neptune. Is also in Aquarius, almost 38 degrees above the horizon, while Saturn is 26 degrees, still not too high, but you can have a look and you will notice that is like one magnitude is not blinking, so it's a planet. For Neptune is not visible to the naked eye. Going to the northeast, to the southeastern sky, you can see Jupiter, and you can't make any mistake because it's the brightest object to the eastern side. And you can also see Uranus on the top of Jupiter. You see all the winter constellations, so the Gemini, Auriga, and also the Taurus here, Orion to the east. Northwest, you can see the Big Dipper is reaching the lowest altitude for this year, while Cepheus is overhead. And the Lyra constellation with the bright star Vega is low to the northwestern horizon. Looking at the southwestern to the northwest horizon, you can see, as I said before, Pegasus, Andromeda, and Cassiopeia also overhead. Here, and Cygnus is the most prominent constellation on the western sky. Overhead, you can see again, you can see Andromeda and the double cluster in Perseus, a lot of beautiful deep sky objects here. Let's go to the solar system. Let's start with the sun. So in August 2024, the sun reached its maximum activity for this solar cycle, but it's still very active. You can look at some websites I mentioned here, spaceweather.com and also the NOAA.gov. Also, if you can install an app on your smartphone, there is My Aurora Forecast, just in case to have a look if there is any coronal mass ejection and maybe possibly a northern light. That's the sun. I took this image a few days ago. It was on November 9 with a monochrome camera. You can see lots of things going on here. I inverted the colors because I wanted to emphasize the prominences and the beautiful filaments and some big sunspots. Probably you can see the sunspot better with the next image here. This is the normal colors. You can see the sunspots here on the limb, here, here, and here. Of course, this was a special hydrogen alpha telescope with a certified filter. The moon will reach its minimum distance to the Earth on December 12 for this duration, and it's only 365,000 kilometers, while the apogee will be on December 24 before Christmas. These are the phases of the moon for the next few weeks. So the first quarter will be reached on Sunday, December 8th, when the moon will set around midnight. The full moon will be on December 15, and this December full moon is called cold moon. I don't need to explain why. The last quarter will be reached on December 22nd, while the new moon will be the end of December. So good imaging time by the end of this month. Of course, the moon is not showing exactly always the same part. We can see a little bit more because there is a libration. It's just the combination of the tidal forces from the Earth and the Sun. And this is what the moon is doing. So we can see probably 59% of the moon during a cycle. So we can see a little bit more the western side of the moon on December 5th, so tomorrow. Yesterday, there was something more happening on the northern part of the moon. And you can see the eastern side of the moon, we can see more than usual on December 18. And the southern part will be on December 16. This image was taken from nthsky.org. This is the website. There are a bunch of opportunities to see the moon and the planets and bright stars be very, very close together. The red rectangle is just a projection of a DSLR camera and 135 millimeters, so you can have a look and see what you can image in the next few weeks. Let's start with Moon and Saturn on December the 7th, so they're a very beautiful vision here. You can see they're in the same field of view. While on the next day, the moon will reach Neptune. If you know, take an image of the moon around this time that's mentioned here, you can at 11 p.m., you know that here there is Neptune. The moon will also be close to Uranus, not in the same field of view, and the Pleiades on December the 12th. That's a good view too. While this is happening the next day, December 13, from our latitudes, the moon and the Pleiades will be very close. The next day, the moon will meet Jupiter. And on December 18, as I mentioned before, look what happened here. So first, if you see midnight, the moon and Mars are very close. A few minutes later, moon, Mars, and the beehive in Cancer will be very close. There is no occultation from our latitudes, but as I said before, spoiler alert, on January 13, there will be a beautiful occultation of Mars visible from the North America a few hours after Mars will reach its closest approach with the Earth. So sign the date, save the date. On the 20th, the moon will be very close to Regulus in Lion, Leo, 1 a.m. It will also reach Spica in Virgo on the 24th. And this is also another beautiful view of the moon, very, very little sliver of moon and Antares. They're very close on December 28th, around 6:45 a.m. before sunrise. And on January 3rd next year, moon will be very close to Venus. And again, we'll meet Saturn. Now, I mentioned the planets, but let's see something more about the planets. So this is taken from the journal. And so Mercury basically will be visible in the last few days of the month, will be visible before sunrise, while Venus is the most prominent object in the western sky after sunset, is an evening object, and same for all the other planets, including Neptune. This is also the brightness, and this is diameter. You can see Jupiter is very big. Now, this is Mercury. The first half of December will be too close to the sun for safe viewing, but it will rise very early in the morning in the eastern sky and will be visible north of Antares starting on the 22nd. Will reach its greatest western elongation, best time of the year, the last opportunity to see Mercury before sunrise on December 25th. Venus is very bright in the evening twilight and finally climbed in the ecliptic in the western sky. So what happened the last few months, the ecliptic was very shallow. Now the ecliptic is getting higher and the separation from the sun will be higher and higher. You can see the shape of Venus. This image was taken from Millennium Square last year. Mars is getting closer and closer and closer. There will be opposition in January, and its magnitude will increase to -1 on December, -1, December 21st. Is well placed for the evening viewing. You can't make a mistake. It's a red object that is moving faster. Interesting about Mars, it will start moving in an awkward way. So the retrograde motion, I did some research here, and basically you can imagine to have a racetrack with two lanes. The inner lane is our orbit, the Earth, while the outer lane is Mars. What happens is that when both Mars and Earth are moving on the same direction, counterclockwise, the Earth, our planet, is moving faster because it's closer to the sun, inner lane. Initially, you see Mars moving forward in the sky, the prograde motion. As Earth catches up to Mars, from our perspective, we see Mars like slowing down, and then when we pass Mars, Mars is going backwards, retrograde motion. Obviously, this is an illusion, it's not real. It's the relative position and speed of the Mars and Earth. and then we'll start working again as usual. So basically what happened, if you see the numbers 1, 2, 3, 4, 5, the blue dot is the Earth, while the red dot is Mars. What happened on projection of the sky, you can see Mars going backwards, starting from here, when we reach and go ahead, and then going back to this direction. This is from Wikipedia. Thank you. And then the star, although it's not the star of the month, is Jupiter because it's well placed, and of course will reach opposition next Saturday when it will be only 34 light minutes away. Interesting things happening on Jupiter. On December 23rd, there will double shadow transit, Ganymede and Io. Is 3:25 in the morning. You can see both the shadows here. This is Ganymede and this is Io. And it happens again on the 3rd. You can see both the moons of Jupiter on the planet itself. It is 4 o'clock in the morning. If you want to see more about Jupiter, there are pages 226, 232 of the Observer Handbook. And you can also go on this website to see where's the great red spot, where the moons of Jupiter, and so on. Saturn is rises early in the afternoon in Aquarius, and the ring plane is exposed at 3.3 degrees tilt, is getting shallow and shallow, and they will kind of disappearing for a few weeks in March 2025. Unfortunately, this will happen when Saturn is conjunction with the Sun, so we won't see this event. On December 8, the moon will occult Saturn, and unfortunately, this event is only visible from Indonesia. Even on Saturn, there are interesting events because this time of the orbit of Saturn, the perspective makes possible to see some of the moons passing in front of Saturn. But the problem is that Saturn is much farther away from the Sun, and the moons are smaller, unless it's Titan. And I found that there are a couple of events on December 6th and December 22nd, although these happen just after sunset, but this is possible to see them, like this one on the 16th is at 5 o'clock. You can see this little shadow, this Titan. And this is the 22nd. So let me know if you are able to see that. Uranus in December is also evening object, is not too far from the Pleiades, and this is image from Stellarium is telling that they are approximately 7 degrees apart. The magnitude is 5.6, while the apparent size is 3.8 arc seconds, and also retrograde until the end of 2024. If you have a small telescope, you can see just a blue-green dot. That's what I can see. But if you take images with a special camera, you can even spot the moons. Can you see them from the image? If not, the next image probably can help you. I can see 4 of the moons of Uranus. Ariel, Umbriel, Titania, Oberon. Miranda is missing here. Sorry. Neptune. This image was taken on September 15 with a monochrome camera. That's why it's black and white. But it's cool because you can see Triton here on the top. And just amazing that you just looking like 4 billion kilometers away, and you can see this small moon. They probably has a liquid ocean in the bottom. I noted this comet, the C2024 G3 Atlas, not because I'm very optimistic, is a grazing comet. That means it can be very bright for a few days, around January 13. But the problem is that very, very close to the sun, and we know what happens sometimes, very often, I would say. The sun-grazing comet has just been destroyed when you're closing too close to the sun. But if they survive perihelion, can be a very interesting event to observe. Some deep sky suggestion for December. I just noted three, like the Rosette Nebula in Monoceros, the Unicorn, the Pleiades, of course, and the Orion Nebula. You can also plan your observation with this free online planning tool that is telescopius.com. So that's the Rosette Nebula. This image was taken on February 2024. Sorry, too fast. And this is its location. See, Orion is, if you make a line, there's a line between these two stars, Betelgeuse, and you can find like all the distance, and this is where the Rosette Nebula is located. It's a giant molecular cloud. So if you have a narrowband filter with your equipment, you can have beautiful images, like this one. The Pleiades. Not much to say. The Seven Sisters. This is one of the most famous open cluster with lots of blue gases. They're here, and if you have a light pollution filter, even from a light polluted area, you can take beautiful images like this one. I will try again as soon as possible. And nothing to say about the Orion Nebula. This is just 15 minutes of total integration time. Unfortunately, it was clouded, and I didn't have any chance to take other images for last year. Let's see if I can try again. And it's so beautiful. You also see the Running Man here, M43. A note about the meteor showers for this month. We have the Perseid in the Ursa Major, and they're active between December 17 and 26. It's caused by the comet 8P periodic Tuttle, and its orbit around the sun every 13 years. The best time to view this shower is at pre-dawn hours where the radiant is higher in the sky. Then there are the quadrantids. They're a very narrow peak. In this case, lasting only about 6 hours. The best night for this meteor shower is January 2nd or 3rd. Probably is around 7 p.m. Universal Time, so is during the day here. Interesting because this meteor shower is generated by not by a comet but by an asteroid. And interesting enough, when it's high enough in the sky, it can generate over 100 meters per hour, but just for a very few hours, as I said before. And finally, this is one of the best meteor showers of the year, the Geminids. And unfortunately, we have almost full moon that will compete with the light. But the good thing is that most of the Geminids are very, very bright. And again, these are generated by an asteroid instead of a comet, the asteroid 3200 Phaeton. You can even catch 120 Gemini meteors per hour during the peak. From mid-evening, the best time of the day is around 2 a.m. Then we have visible passes of the International Space Station. This is a website, heavens-above.com. And you can see there are a few at the beginning of December, not particularly bright. The brightness is minus. This was yesterday. Minus 3.6 is very good. -1 is good enough. But if you scroll the next few days, you can see on December 16, minus 3.8. That's a very bright one. It's happening early in the morning, I would say. And again, the next few days, you can see minus 3.8, December the 30th. In January, again, we have minus 2.3. So the brightness with the minus sign and the higher number, it means usually that is almost overhead. This is happening on December 29, is the brightest one, between 7:12 and 7:20 a.m., when the maximum altitude will be 64 degrees and the distance will be only 462 kilometers. You may run this simulation for your location very often because this is changing quite a bit because there are continuous correction of orbit, and this can definitely be a different time. Even more for the International Space Station and Tiangong Lunar and Solar Transit. There is this website, transit-finder.com, when you can also see if there is any pass of this bright object on the front of the moon and the sun. Of course, if it's going where the sun, never look directly at the sun. And as I mentioned, the transit properties may significantly change depending on observer's location, especially long travel distances. So recalculate 1 or 2 days before the pass. Space exploration, there are a bunch of Starlinks, not much to say. And there is a launch site on December 4th, so it should be today. It already had happened from India. The Indian Space Research Organization, the Proba 3 spacecraft, on behalf of the European Space Agency. And then we have a Vega launch and a Falcon 9 with other Sirius XM, other satellites. And with that, I think I'm done. Thank you so much for your attention. If you have any question, just ask. Thank you, Tom.
And thank you very much, Claudio, for a wonderful presentation. Do we have any questions?
Yes, we do. From Zapfan, he asks, can you see the Chinese space station from there? I'm too far north, and he's asking if we can see it from Toronto.
The question is, can you see the Chinese space station? I'm from Toronto.
Yes, you can. Yes, you can. As I showed you before, this is a puzzle. It is much smaller because also the distance you can see is much far away. If you remember the slide before, so the International Space Station was only 462 kilometers, the closest, while the closest passage of the Chinese space station is 1,000 kilometers. So it's much smaller, and also the diameter, of course, is much smaller. So the answer is yes, but you have to know where to watch, and yeah.
Okay, thank you. Any more questions?
We have no more questions.
All right, that's it for questions. Okay, Claudio, thank you very much. And we will go quickly to fun facts while we switch over for our next speaker.